In previous videos, we were looking at what would happen when the lens was outside of its focal length. So if you remember, the focal length of lens number 1 is about 10 centimeters. And if we were positioning the lens, in the 12, 15, 20 centimeter area, well, we would get a real image that would be projected onto a backdrop here. And we could measure the image distance, we could measure the object distance and determine things. Let's see now what happens when we bring the lens inside of the focal length. Now let's put it at the 8 centimeter mark now. So you'll notice that one thing that happens is that we suddenly can't project onto a screen. There's no spot where you can stick a screen that will get us an image. Which means that now suddenly our image is a virtual image. It exists only inside the lens. It kind of is positioned somewhere back here. Let me show you what that looks like. I'm going to zoom in here a little bit so you can see this is the object itself, and I'm going to slide us into a view where we can see it through the lens. There it is. Let's do it again. There's the object, and then there is the magnified version of the virtual image that we're looking at right now. So what that's telling us is that as we're inside the focal length, suddenly we get a virtual image that is a magnified version. This is actually acting as a magnifying glass. Now let's do some calculations. I want you to use this object distance and the focal length. This is for question 6. I'd like you to calculate the image distance and then add to the question, what does the sign of the image distance indicate about the position of the image? For question 7, I'd like you to calculate the magnification of the lens and answer the question, what does this magnification indicate about the image orientation?